Alright guys, so this is going to be our first video, I think, for algebra, and what we're going to do is we're just going to work through the lessons, alright? I'm just going to work through these lessons in these videos. I'm going to try and keep them as short as I can, because I know you guys have, other things that you need to do, and I know that this isn't the only thing that, the only school class that you have. So I'm going to keep them as short as I can. I'm just going to go through as much of this as I can in that brief amount of time. So, looking at lesson 9, lining up quadratics. So we're going to graph each function. We're going to find the vertex, Y-intercept, and X-intercept, and write out the intercepts as points. So first off, we're looking at this, and we can see that our equation is x minus 1, x plus 3. Now our X-intercepts are where we cross the x-axis, and our y value there is 0. So we're just going to set these equal to 0. So 0 equals x minus 1 times x plus 3. And now this brings up this really cool property we have called the zero product rule, meaning that if two things multiply together and equal 0, one of them has to equal 0. So we're just going to split both these up. We're going to say x minus 1 equals 0, and we're going to say x plus 3 is equal to 0. And then we just solve that. So we get x equals 1, and we get x equals negative 3. So our x-intercepts are 1, 0, and negative 3, 0. It was just as simple as that, guys. And then our y-intercept, we're going to plug in 0 for our x value, because that's where we're going to cross the y-axis. So we plug in 0. 0 minus 1 is 1. 0 plus 3 is 3. So negative 1 times 3 gets us negative 3. So we're going to have our y-intercept at 0, negative 3. Now the line of symmetry in the vertex, what we have to do there is we have to get this into vertex form. So what we're going to do is we're going to multiply this out and get it into standard form first. So we're going to get x squared plus 2x minus 3. And this form right here, the standard form, it's a lot easier to see our y-intercept that way. So then once we move it to, we're going to need to move it to vertex form. So we have to go x squared plus 2x plus something minus 3 minus that something. So if we take 2, divide by 2, we're going to get 1. And 1 squared is equal to 1. So we're going to add 1 here. We're going to subtract 1 out here. So if we factor this right here, we're going to get x plus 1 squared minus 4. So our vertex is at negative 1, negative 4, meaning our line of symmetry is x equals negative 1. And then we just graph that. So they didn't give us our x-axis or y-axis, so I'm going to draw that in, and this is going to be a terrible, terrible graph, guys, trust me. So our x-intercepts are 1 and negative 3. Our y-intercept is at 0, negative 3. And our vertex is at negative 1, negative 4. So we're going to go down here to negative 1, negative 4. And remember, guys, these are symmetric. So what we're going to do is we're going to make one side look just like the other. And that's all we have to do for these, guys. I'll do one more of these, and then I'm going to have you guys finish out number 3 by yourselves. So looking at number 2, we can clearly see our x-intercepts have to be at 2 and 6. Our y-intercept, we're going to plug 0 in for these x's. So negative 2 times negative 6 is 12. Times 2, that gets us 24. Now we need to put this into standard form to get it to vertex form. So I'm going to leave it a specific way, and you guys will see why I do that. So we get 2 times x squared minus 8x plus 12 And now from here, what we're going to do is we're just going to pull this positive 12 out, and we're going to put it out here. So we're going to get 2 times x squared minus 8x plus something minus, and when we move it out, we have to multiply it. Or sorry, plus 24 minus that same something. So we're going to get 8 divided by 2 is 4. Square that, we get 16. So we plug that 16 in here and here. Oh, sorry, that should be 16 times 2. So that should be a 32 out here. Which means our vertex form is 2x minus, sorry, that should be a minus, that should be minus. Four squared minus 8, which gets us a vertex of positive 4, negative 8, and a line of symmetry of x equals 4. Now we just need to graph this. So let's graph our x-intercepts first. We have it at 2 and 3, 4, 5, 6. Our vertex is at 4, negative 8. So way down here. Now guys, remember, with these, they're symmetric, and we have this times 2. So we're just going to put this point right here, because we know that's where it has to be. Alright, so I'm going to leave 3 for you guys to do, but this number 2 should be pretty easy. Alright guys, so for number 4, based on the examples above, how can we use the quadratic function in factor form to find the line of symmetry of the parabola? Well, an easy way to do this is that the line of symmetry in the parabola has to be halfway between those two x-intercepts. If you look back up here at number 2, it's halfway between 2 and 6, and our vertex here, our line of symmetry here, is halfway between those x-intercepts. So the vertex must be, or sorry, the line of symmetry must be halfway between. Halfway between zeros. Now our zeros are the x-intercepts. How do we find the parabola, or the vertex of the parabola? Well, we take that line of symmetry and plug it in. So we're going to just say plug in line of symmetry. Now, the x-intercepts of the parabola, what we're going to do is we're going to set each of those factored pieces equal to 0. So we're just going to say set equal to 0. And we solve each of those independently. The y-intercept for the parabola, we plug in 0 for x. We plug in 0 for x. How do we find the vertical stretch? It's out in front of that factored form. It's the number in front of the binomial. Or it's the number that's attached to the x. Okay, so let's look at, if we look back up here, number 2, it was the number that was out front here. That was our vertical stretch. Now that number could have been inside if we were graphing a different parabola. So, again, the line of symmetry is halfway between the zeros. The vertex, we plug in that line of symmetry. To find the x-intercepts, we set it equal to 0 and solve each one independent. To find the y-intercept, we plug in 0 for our x's, and to find the vertical stretch, it's either the number in front of the binomial, so the number out in the very front, or it's the number that's attached to our x. Now, we're going to choose two linear functions and write them this way, where m is the slope of the line, and we're going to graph them. So I'm going to choose 3 times x minus 2, and no, I'm just going to go with a 1. X plus 3. Alright, then we just need to graph these two functions. So, let's try and do it halfway. Terrible line. Terrible line. Okay. So if we put this into slope-intercept form, we're going to get 3x minus 6 and x plus 3. So x plus 3 is very easy to graph. It's going to go through here, and it's going to go this way and this way. Now 3x minus 6, we're going to go down to negative 6. So 1, 2, 3, 4, 5, 6. That's where it crosses. And we're going down 3. If we go to the left and we're going up 3, that's going to move to the right. And it would be like right there. And that's our line for that equation. Now, we need to graph the product of these two linear functions that we've chosen. So what we're going to do is we're going to multiply these two together. So we're going to get 3x minus 2 times x plus 3. Now my zeros are going to be at positive 2. Positive 2 and at negative 3. You guys can clearly see already the zeros were already on the graph. Now our vertex is going to be halfway between these two. So we're going to need to go to negative 1/2. And if we plug in 0 for x, we're going to get negative 2 times 3 is negative 6, negative 18. So it's way down here, guys. Way, way down here. But it should look like this. And if you guys look at it, we have a parabola there. So a parabola is just the next step above these linear functions. And when you take two linear functions where they cross the x-axis, will be the 0 if you multiply those two together, which is this function right here. So for the linear functions, the x-intercepts of the linear functions are the x-intercepts of p of x. So x-intercepts of linear are x-intercepts of p of x. Now that's a really important thing, guys. This really shows you what's going on with these functions and some really cool things that you can actually see as we move forward in math, and you'll be able to see clearer once we get to like calculus or, you know, some really cool things when you guys get there. Trust me, you guys are just gonna absolutely love it. So the relationship between y-intercepts of the linear functions and y-intercepts of p of x. Now, the y-intercept. So the y-intercept of this function up here was 3. This one went down here was negative 6. Now if you guys look, negative 6 times 3 gets us that negative 18 that we're going to have down here. So it's the y-intercept multiplied So it's the two y-intercepts multiplied by each other. And the reason that this exists is because if you look up here at the equation we've made, if you just plug in a 0, which is what we would do for each of those, we're going to end up multiplying those things together. That's why it ends up being this. So, given this parabola, sketch two lines that can represent its linear factors. Now, linear factors are just going to be those lines that we multiply together, or the equations of those lines that we multiply together to get to this. So we know one of them has to have an x-intercept here and an x-intercept here. We also know that their two y-intercepts have to multiply to get us -4. So let's say this one goes through +2. This one goes through, and we'll say this one goes through -2. So now we have a y-intercept here and a y-intercept here, which means that if we multiply these two together, we will get this y-intercept here, and we have our same x-intercepts. So these two lines can be a linear factor of this parabola here, and we'll just write those out. So one of them is, what is that, 2x - 1. Right? Yes. Wait a second, I gotta make sure that's correct. Because that's, nope, sorry, +1. Sorry guys, 2x + 1. And then this other function here, this other line, is going to be, so rise over run 2/3. And then we'll call it x - 2. Or 1/3, no. So pull that 2/3 out. We're going to get x - 3. Sorry guys, I really had to think about that for a second because it has to multiply out to be this, and 2/3 times -3 does get us that -2. So if we multiply these two things together, if we show them multiplied together, we're going to get 2x + 1 times 2/3 x - 3. Those are our linear factors. So how did we use the x and y intercepts? Well, what I did is I broke apart the y-intercept into multiples of -4. The x-intercepts, I knew they had to be exactly the same. Does that make sense, guys? That should make sense. Hopefully that makes sense. Now, are these the only two lines? No, these are not the only two lines that can represent this. There are infinitely many lines. Almost infinitely many lines. There are a lot of lines that we can use to do this. Alright, guys? I mean, one other line, instead of using this 2x + 1, I could have easily used a y-intercept that was here, paired with a y-intercept down here at -4. We just have to make sure that these two things multiply together to get us that -4 and have those same x-intercepts. So, to write the equation of the parabola, we just multiply these two things up here together. So 2 times 2/3 gets us 4/3. And then we're going to get x + 1, x - 3. And that's our factored form of the equation. And now this is the ready, set, go. I'm going to record another video for you guys on Thursday that will go over lesson 10. And I'll do one more video on Friday that will go over lesson 11 for you guys. Next week I'll do lesson 12. We'll do a nice review video, and then next Friday I'll give you guys a test. Don't worry, you guys will have a lot of time to do it. You guys will I'll probably give you a week to do it. It'll be a fairly simple test over this stuff. There's going to be a lot of review that you guys are going to have online. There's going to be a lot of packet review for you guys. It'll be great. You guys don't really have to worry about your grades. I'm figuring this out as we go along, and I'm going to take it easy on you guys in the grading of that. I understand that you guys have a lot going on, and that this is not ideal for anybody. So, another video is coming out Thursday and Friday, and then we'll see how next week goes.